Okay, we're going to look at differential equations. A differential equation is when you've got something that's differentiated, written as an equation. So something that's been differentiated and it's an equation. So there's an example, dy by dx is equal to x squared minus 7, or f dashed x is equal to 5x plus 1. Now remember that integration is the reverse process, the inverse process of differentiation. Now, thinking about if you differentiate 6x squared plus 9, that will give you a result of 12x because the constant vanishes. If we then differentiate 6x squared minus 11, we would get the exact same result because the constant vanishes. If we then look to integrate 12x, then it could be a reasonable result to say it would give you x squared plus 6x squared plus 9, since when we differentiated that we did get 12x. But it could also be reasonable to say that the answer is 6x squared minus 11, since we differentiated 6x squared minus 11 to also get 12x. Now the issue being is that we don't know whether a constant existed in the first place, so we've thought about that before. When you integrate an indefinite integral, for example x squared, then you put down a plus c being the constant of integration. Now that could hold a 0 value or it could hold a non-zero value. Okay, so we're going to try and identify a value for c given different information under the outcome of differential equations. Okay, so let's just see how this would work. So we're going to find the equation of the original function. So we want to find f of x, the original function, given the following information. So the following information being that I'm given that f dashed x is equal to 4 minus 3x, and that I know that we pass through the point minus 1, 1 with the function. Okay, so to get f of x, I'll need to integrate f dashed x. Okay, so that is then the integral of 4 minus 3x. Okay, so integrating f dashed x will give me the original function f of x. Okay, so integrate 4, that will give me 4x, and that will be minus 3x squared over 2 plus the constant of integration. Okay, so what I know now is that when the x coordinate is minus 1, I'll get the y coordinate of 1, so I can now sub that in. So the y coordinate is 1 when the x coordinate is minus 1, so that's 1 equals 4 lots of minus 1 minus 3 lots of 1 squared over 2 plus the constant of integration. Okay, so that's 1 equals minus 4 minus 3 over 2 plus the constant of integration. Okay, so the constant of integration c is equal to 1 plus 4 plus 3 over 2. So that's 5 plus 3 over 2, which is 10 over 2 plus 3 over 2, which is 13 over 2. I've now identified c, so I can write out the original function, which is f of x equals 4x minus 3x squared over 2 plus 13 over 2. Final answer. Okay, let's try another. The gradient of a tangent to a curve is given by dy by dx is equal to 2x minus 3. The question then says, if the curve passes through the point 4, 4, find its equation. So that means I'm looking for y. Okay, so y equals the integral of dy by dx. So that is the integral of 2x minus 3. Okay, so integrate 2x, that will be 2x squared over 2 minus 3, the constant becomes minus 3x, and I need my constant of integration. I can now identify the constant integration because I know the x coordinate is equal to 4 when the y coordinate is equal to 4, so I can sub that in. Where I see y, replace it with 4, and where I see x, at the same time replace it with 4. Okay, so that will give me 4 equals 2 lots of 4 squared over 2 minus 3 lots of 4 plus c. 4 equals, 4 squared is 16, times that by 2 is 32, 32 divided by 2 is 16, minus 12 plus c. 4 equals 4 plus c, so c is equal to 4 minus 4, and c is equal to 0. Therefore, the function can now be written out as x squared minus 3x. Final answer. Okay, let's try another. Find the equation of the curve y when dy by dx equals 1/5 x squared and the curve passes through the point 0, 4. Okay, so when the x coordinate is 0, the y coordinate is 4. Okay, so y equals the integral of dy by dx. That is the integral of 1/5 x squared. So add 1 to the power, divide by my new power. That's 1/5 x cubed divided by 3 plus c. Okay, so 1/5 divided by 3 will give me a 15th, so that's 1/15 x cubed plus c. Y is equal to 1/15 x cubed plus c. Where I see x, I can replace it with 0, and where I see y, replace it with 4. So 4 is equal to 1/15 of 0 cubed plus c. So 4 equals 0 plus c. C is equal to 4. And the original function then is 1/15 x cubed plus 4. Okay, let's try one final question. F dashed x equals 6x minus 5 over x squared. Find f of x when f of 1 equals 6. So that's just saying that an x coordinate of 1 will generate a y coordinate of 6. Okay, so exact same as all the questions. Okay, so the integral of f dashed x will give me the original function f of x. Okay, so that's the integral of 6x minus 5 over x squared. Let's prepare to integrate with this one. So 6x minus 5x to the minus 2. Okay, so 6x squared over 2 minus 5x to the minus 1 over minus 1 plus c. Okay, so 6x squared over 2 is 3x squared. Those two negatives give me a positive 5x to the minus 1 plus c. Let's bring that power back down. 3x squared plus 5 over x plus c. I can then make my substitution. Where I see x, replace it with 1. Where I see f of x, replace it with 6. So 6 equals 3 lots of 1 squared plus 5 over 1 plus c. 6 is equal to 3 plus 5 plus c. C is equal to 6 minus 8. C is equal to minus 2. So the original function then is f of x equals 3x squared plus 5 over x minus 2.